You can probably see my screen, hopefully announcing the title of this morning's session, Low Carbon Regeneration, Building Sustainable Built Environments. Morning, welcome. My name is Andrew Wilson. I work for the Supply Chain Sustainability School. It's a pleasure to be hosting this event this morning. Obviously, with such a tremendous international focus on Glasgow and Scotland, it's great to be talking about the technologies and the innovation that can drive us towards the target of net zero by 2045. We've got several expert speakers this morning. I'm just going to introduce very quickly who they are and what they're going to be talking about, and leave you in their capable hands. So let's have a quick look at the agenda. Just a few words of welcome from myself. Obviously, we're joined by Martin Mackay and Hugh Moore from Clyde Gateway. Martin's Executive Director of Clyde Gateway, and he's going to give a strategic overview about their integrated infrastructure approach and reference some of their core projects and update everyone here this morning on those. So it's great to have your involvement, Martin. Thanks for being with us. Hugh, Martin's colleague, is the Energy Network Manager for Clyde Gateway. Hugh's going to focus in on a little bit more detail about two of the core projects that Clyde Gateway have underway at the moment, Community Energy Project at Dalmarnock and Demand-Driven Grids, or so-called D2 grids. And it's great to have Hugh joining us this morning to go into a little bit more detail about the technology and benefits of this approach. Then we're going to pass across to Presley Maguire, who's from Scottish Water Horizons. Morning, Presley, thanks for joining. Presley's going to talk about heat from wastewater and using that hidden and renewable energy source to provide heat for buildings and the benefits that that can bring. Presley's going to be referencing some of the other projects that have been successfully concluded around Scotland, but also talking about their work at Dalmarnock, at Clyde Gateway, the energy centre there, and also the Equilibrium Leisure Centre in Campbelltown, also in Glasgow. Last but by no means least, we've got Anne-Marie Gillespie joining us from the Construction Scotland Innovation Centre and also the Energy Technology Partnership. And Anne-Marie, morning Anne-Marie, is going to be talking about broader contribution and support that the CSIC offers to industry, not just in Scotland, but across the UK, working with several partners and stakeholders, talking about energy efficiency more generally in the built environment and low carbon technologies in the built environment, to sum up their work and reference other initiatives that are taking place in this space. Before we get started, just very quickly, if there is any questions, if there are any questions rather, just please drop them into the chat function within Zoom. We're recording the session and we'll be providing a link to that recording to everybody on the call this morning, and we'll also be sending PDF copies of all the slide content. So don't feel the need to try and write reams and reams of notes. You can ask questions to Martin before he leaves us this morning. But without any further ado, I'm going to pass across now to Martin. Thanks for joining us, Martin. It's great to have you with us and to hear more about Clyde Gateway, your progress and plans for the future. Thanks a lot.
Well, thank you. Good morning, everybody. So I'm going to do the usual technology bit and just try and share the screen.
I've stopped sharing mine, Martin, so okay. There you go.
So it should be there. Okay, hopefully everybody can see that okay.
Yes, we can see that. It's not on slideshow yet. It should come through once you launch that. Okay, so
brilliant. There we go.
Yeah.
Well, thank you. Good morning, everybody. So I think, like most of us in Glasgow and seeing COP26 around us, it feels like Glasgow is the centre of the world at the moment. You can't turn on the BBC News or any other news outlet and not see something about COP26 and the challenges that faces. So it's been for me certainly, it's been a really positive few days, and it's been great to see the participation across the industry. I wanted maybe to start with some reflections on COP. I'm then going to come on and talk about our green regeneration and innovation district and some of the projects within that. And at the end of the presentation, I'm going to finish with a line that our Chief Executive gave a presentation the other day there, which I thought was fantastic, and I'm going to keep stealing, but I'll bring that one on at the end. So first of all, some observations around COP, and I think I've had 3 takeaways over the events that I've been at the last few days. The first takeaway is that everybody's agreed on the outcome, and by that I mean I think there is now recognition across all of the countries and participants that the 1.5 degree target is an absolute. We must stay within that parameter, and that there is an acceptance now that everybody kind of has to work towards that outcome and has to do everything that they can to help their industry, their society, their communities sit within that. So that's, I think it's been a change. The second point, and probably one that I guess is relevant to today's discussion, is that in many of the discussions I've had over a few days, there's a recognition that the technology that's required, the expertise that's required in order for us to achieve a net zero environment, all of that already exists. Scotland, as an example, has been an industry leader in terms of things like wind power and others. And I've seen a hugely exciting project the other day there that was looking at tidal energy. One of the largest tidal arrays in the world is located here in Scotland, and the ability for that to scale up. And that's just one example of the types of projects that are out there that can help us achieve net zero. And in Clyde Gateway, you'll hear about our kind of energy projects as we go through today. But again, it kind of shows you that at a local level as well as at a national level, we can do what we need to do. The tools are there at our disposal. We just need to unlock them and drive the agenda forward. And then the other element that kind of came through from that, from the presentations that I've seen over the last few days, is that the finance is there. So I was very fortunate to be in one of the finance events that was hosted with all of the kind of big bankers and main banks were there. And all of them were saying the same thing. There is no shortage of finance. There's maybe a challenge in getting some of the projects to viability in the early stages, but there's no shortage of finance. So there's a real opportunity here for us collectively to make that drive towards net zero. So I'm really looking forward to seeing what's going to happen over the remaining period of COP. I've realised I'm on the last slide at the moment, so I'm going to scale back. So just try and avert your eyes while you kind of see the good stuff, and I'll get back right to the start. So delighted to be speaking here today. I'm going to say a few words firstly about Clyde Gateway as an organisation, and hopefully some of you know us as an organisation, but I'll maybe just give a little bit more detail. So we are a partnership between South Lanarkshire Council, Glasgow City Council and Scottish Enterprise. So those are the 3 organisations that own Clyde Gateway. We are supported by the Scottish Government. And we operate as a charity and with a trading subsidiary. And that's an important point about the trading subsidiary, because part of the model that we have for regeneration in Clyde Gateway is based around that structure. So as much as we have charitable and charitable aims, then we also work commercially as well. And to give you an example of that, we have around £10 million of assets currently under disposal within Clyde Gateway, and that's money that we will bring back into the Clyde Gateway area, recycle and invest into other projects. And with the charity, we also have the opportunity within the trading subsidiary then to gift aid funds back up to the charity that allows them and their colleagues to invest into other projects within the area. To give you a kind of overview of that, then our organisation is rooted in 3 things: and people, probably the most important aspect of the work that we do, and in place and in jobs. And what we're about is transforming the social and economic fortunes of the East End of the city. Hopefully you will be able to see my cursor, but if not, I should be able to make some description and give you an idea of where we are. So Clyde Gateway is around about 1.5 miles from Glasgow City Centre. This is Glasgow Green that runs on the periphery of our boundary, just next to our headquarters at Bridgeton Cross. Running through the bottom of Clyde Gateway is the M74 completion, a project that had been decades in planning before Clyde Gateway arrived. And I guess if we were talking about green regeneration now, we would be talking differently about infrastructure. But that was a critical dependency for us as an organisation in order to unlock the potential of the East End. Coming off of that is the East End regeneration route, now renamed the Clyde Gateway, which then runs up towards M8. To give you an idea of the geography, obviously we've got the River Clyde runs through the area and it loops around Cunningham Loop, and I'll speak about that project briefly later. And down at the bottom here, we've got Hampden Park and Tory Glen. Football sits down at the bottom. Up at the top, Celtic Park and the Emirates Arena and Velodrome. At the far end of our boundary, at the motorway junction, we have our industrial development, Clyde Gateway East. That's now almost complete, as the development is home to companies like Network Rail, Eden Mill, DHL are there, Torishima Pumps. So they have a Japanese company at their headquarters there. So we've been able to bring real jobs and real businesses to the Clyde Gateway area. And we've created over 5,000 jobs in the time that we've been working. The Fareham Cross and Rutherglen district here, we have a Rutherglen low carbon zone, as what's called, it's now called Rutherglen Links, and I'll give an example of what we did there later on in the presentation. So running through the area, 3 train stations, Rutherglen, Kilmarnock and Bridgeton, and that provides us excellent connectivity back into the city centre. We have around 6 trains per hour on that line, and it's one of the most heavily populated lines in the network. So we'll speak a little bit about our green regeneration and innovation district and the infrastructure approach that sits alongside that. I mean, we accept that within a regeneration area like ours, it requires considerable investment, it requires new development, that brings with it carbon intensity. But you can't just look at the buildings on their own, you have to look at everything that's sitting around that. So our integrated infrastructure approach goes through these steps. Firstly, the remediation of brownfield land. We then move through flood management, surface water management, green space and biodiversity, then the reuse and renewal of existing assets. Then we're on to building energy performance, then district heating and cooling, and then sustainable transport. We make those points, and that what we have to be able to do within regeneration areas is prepare those areas properly for development that is low or zero carbon. And then when we develop those areas out with buildings, that we're doing so in the most sustainable way possible. We do a lot of work with a whole range of partners and colleagues, and if some of my colleagues at University of Strathclyde talk about their climate neutral innovation district, that has similar characteristics to what we're trying to achieve here at Clyde Gateway. So it's not just about low carbon, it's not just about energy performance, it's about climate resilience and adaptation as well. And adaptation has been something there's been some discussion on over the last few days as well. So within the grid, as we define it, we have core projects. We have the British Geological Survey Glasgow Observatory, so that's located in Cunningham Loop. And that's a test site that's looking at energy from mine workings. It's a research-led project, and one that we think will have huge benefits for Scotland, and one that we feel that in terms of the longer term, we can look at an energy transition that includes mine workings. The second project then is a community energy project in Kilmarnock, and Hugh's going to speak about that in a little bit more detail, and as well as the D2 Grids project, which is fifth generation district heating and cooling. And you know, we're a really committed team at Clyde Gateway, and the Green Regeneration Innovation District wouldn't have been possible had we not had those first 3 projects that sit as a backbone of what we're trying to do, and Hugh takes Hugh's credit for the work that he's been able to do along with our partner Scottish Water and others to bring those to fruition. We then have green space and biodiversity. So Cunningham Loop, hopefully some of you have been there, Mulsmire Park and Tory Glen, an emerging project which is the Kilmarnock Riverside Park that pulls it all together, and then sustainable transport. We actually have a bus in Clyde Gateway, it's called CG01. We've only got one at the moment, I hope to have more. Currently runs on petrol, I hope to have it electric. But the ability to move efficiently through the area and have an area in which you can live and work is a central part of what we're trying to do with the grid. So active travel, key routes, spaces, walking, cycling, all of those types of aspects are important. We want people to walk out the front door of their home and walk 10, 15, 20 minutes along to their office and be able to enjoy the green space and work within, I guess, what we probably have as a kind of 20-minute neighbourhood. So to give, again, just to come back to the map and just to give you a little bit of context of where those projects are, then we have Cunningar, the Forest Park, which sits next to the Athletes Village and is connected by a new bridge. This is the Shawfield and Kilmarnock area combined. So those are the strategic locations that really the energy projects sit within, and that we're using those energy projects alongside a range of other initiatives to really lever up the development of those areas, and then Tory Glen and Walsmire Park over at the edge. And you can start to see how those projects can link together. There's a network of walking and cycling routes and bring all of that together. And then just to zoom into that in a little bit more detail, then, you know, if we're drawing a hard red line boundary around our grid, then this is where it currently sits. But I'm hoping to stretch and move that as we move through. So you'll see the British Theological survey on the right-hand side of the slide, the Energy Centre, which my colleagues will come on to speak about, and some of the projects that sit around that. So our red, which is our commercial development that we are promoting within the area, Kilmarnock North, we hope to start on site on that very soon. Eastworks, which I'll come on to speak about, and then Shawfield, which has the Red 3 building, our Red 3 business suites, sits as part of that. So coming through that kind of integrated infrastructure approach, I want to maybe just give an example of kind of against each of those headings. And the first of that is the remediation of brownfield land. I'm probably going to be slightly controversial, you know, but we've declared a climate emergency. Yet we're still building car-dependent neighbourhoods because there's been a decade in the planning. And I can point to 3 or 4 projects, you know, within about 10 miles of Clyde Gateway, where we're building developments that are remote from infrastructure, that drive people into car dependency, and mean that they can't live in the most sustainable way. So if we are to achieve net zero, if we are to achieve these kind of low and sustainable neighbourhoods, then we really must deliver on the remediation of brownfield land. And that takes time, it takes expertise, and it takes money to get those development sites ready to accept development. Our kind of flagship remediation project is Shawfield. It was probably one of the most heavily contaminated sites in Europe. And we took that site, we acquired almost 42 different property interests in order to assemble the site. And we then went through a programme of remediation, which includes the injection of chemicals into the groundwater in order to remove the contaminant flow from the site to the River Clyde. And alongside that, for many organisations, that probably would have been enough just to clean the site. But what we wanted to do was to really bring it back into productive use. So we levered in the infrastructure to support the development of Shawfield, and we've delivered the first building on the site, which is the Red 3 business suites. And this Shawfield site will then become the centre of a number of the activities that we are undertaking at Clyde Gateway. The next point then is around flood management. I've used the image of the bridge because that connects over to Shawfield. It reduces the walking time to Kilmarnock Station, and it will also provide a key link for us in terms of the energy projects and the ability to bring the network across the river to service the Shawfield site. But if you come to Clyde Gateway and you walk along the river and you see some of the new developments that are happening, in particular the big housing scheme by Link Group and others, then what we have done from the outset is design our developments to be resilient to flood. You know, we accept that there will be flooding events, and it doesn't matter where you are in Scotland or elsewhere. You know, there, even with staying within 1.5, we will see the impacts of climate change in the years to come. But what we can't do is leave our communities behind. So what we have been doing is designing in flood management from the outset. I'll be teaching some some people that suck eggs here, but flood management and flood mitigation is different from surface water management. They are intrinsically linked, but you know, in communities like ours and many historical communities, we have the kind of legacy of combined sewers, and we're not going to be able to completely retrofit a new network within the area. But what we are doing is retrofitting surface water management within the area. So that allows us to bring that to bring water out of the combined sewer to release capacity for development and to reduce the impacts of flooding. So if you come to Clyde Gateway, you walk out of the Marnock train station, you come onto the walkway, this is what you're faced with. The swales that we have retrofitted into the environment to handle the impacts of surface water management. We've been part of the Metro Glasgow Strategic Drainage Partnership since the outset. And I was speaking to somebody yesterday who was saying, well, you know, the flooding in Glasgow didn't seem that severe recently. There are certainly areas of the city that have been impacted, but actually it's some work that Glasgow, Scottish Water, SEPA and others have been doing over the last decade that's helped mitigate some of the impacts of flooding and surface water flooding within the area. So green space and biodiversity is a hugely important component of what we do. It's part of the lower carbon approach, but it also impacts on the health and well-being of our residents. And one of the projects that we're most proud of is Cunningar Loop. That was developed by Forestry Land Scotland, who own and manage the site at this point, and it's connected to the Athletes Village by a new bridge. We've received money from Clyde Mission. We're extending this area by over 6 hectares, planting thousands of new trees and providing areas for people to get out and walk and enjoy the river, enjoy the green space. But again, it gives us, you know, huge kind of green areas within the Clyde Gateway area that helps kind of contribute and mitigate against some of the wider development that we are undertaking. If you've not been to Cunningar Loop, I encourage you to do so. I can't say too much about it, but at the early part of next week, we will be launching the COP Legacy project within Cunningar Loop. So reuse and renewal. This is the Eastworks development in Clyde Gateway. It's currently on site. Clark Contracts is the main contractor. And we have, this is a former gasworks. So we had the gasworks building, the purifier shed and the VTOP house. And that's effectively where they treated the coal in order to turn it into gas. And it's one of the few remaining historical structures that we have left within the Clyde Gateway area. But we've been able to bring that building back into economic use. We're creating a whole range of business spaces within Eastworks. We're also proposing to put one of our Red Tree developments in there. And this will be the first building that will be connected to the district heating project that my colleague Hugh will take you through. Sorry, I've been out networking over the last few days, so I'm a bit hoarse, but a shock to the system to be speaking so much. So that project will be connected to the district heating along with new homes within the Clyde Gateway area. We've delivered over 3,000 new homes. We've got another 1,500 in the pipeline, and that's part of our attempts to increase the population within the area. So just the last couple of slides. So working through that integrated approach. So then on to building energy performance. District heating, cooling, and building energy performance all go hand in hand in my view. However, there is always going to be a place for fabric first approaches. And this was the first building that we delivered at Rutherglen. This was based on a fabric first approach, and we adapted the systems within the building in order to achieve the lowest carbon consumption that we could with this particular building. It's still one of the best performing office developments in Scotland, and it shows the exemplar of what can be achieved with a fabric first approach. So whilst we're very much committed to district systems, we believe that's an important part of developing large-scale regeneration areas. Then fabric first is also going to be a very important component for development going forward, and certainly for communities and areas that can benefit from the connection to district systems. So then district heating and cooling. Just sitting behind that is the lease building you'll see in the background, and that's one I would hope that we'll be able to retrofit in the future. But district heating and cooling is a hugely exciting project. It's, you know, in terms of the higher temperature network that she'll tell you about, you know, kind of tried and tested infrastructure that's been used elsewhere and that we can benefit from here in Scotland. So I won't say too much about that. I'll leave that to the presentations later on. And then finally, sustainable transport. So, you know, how we heat our buildings, you know, and then how we transport as well. These are the kind of big carbon users. So this is the Marnock Station, which we renewed for the Commonwealth Games. We increased the frequency of services on that line, and we've integrated that with the walking and cycling routes as well. So we, you know, if you want to pick up a bike at the Marnock Station, you can do that. And we've got the legibility in the area that when you arrive at the Clyde Gateway area, you should be able to see quite clearly where you need to go in order to move around the area. So being able to get to an area where people can live and work and where we have lower car dependency is what we want to get to. So thank you for listening. I'll finish on the bridge again, the smart bridge. But back to my line that my chief executive came out with yesterday, and he said we think about areas like Clyde Gateway in terms of their past glories, but they deserve future glories too. And what better future than net zero, which I thought was a nice way to put it. So thank you very much. I'll try and stop sharing now, but happy to take any questions.
Thanks a lot, Martin. That was a superb introduction to this morning's session, just giving us that overview of your work and several areas of interest, you know, the transport that you finished with and the inbuilt resilience that you're managing and providing to counteract flood risk, and about the adaptation to climate change as well as mitigation was really interesting. And of course, we're going to hear a lot more, as you've said, about the district heating and cooling project with Hugh's input coming up, and particularly the demand-driven grids, the D2 grids that Hugh will be speaking about also. So just very quickly, has anyone got any questions for Martin? Because he does need to leave. He's got a different engagement now this morning. If there are any quick questions, then now's the time to ask. I'm sure Martin wouldn't mind also receiving emails with more detailed follow-up if anything needs to be clarified from Martin's presentation this morning.
Yeah, I'm more than happy to do that, to take further questions. And, you know, when time allows, if anybody wants to come and visit us at Clyde Gateway, there's always an open invitation to do so.
Superb. Thanks a lot. Okay, well, I'll send your slides around, and thanks again, Martin, and enjoy the rest of your day and have a good weekend. Thanks for joining us. Yeah,
you too. Thank you for inviting me, and hopefully you have a good session. Thank you. Goodbye.
Great, thanks. Now on to Hugh Moore, Martin's colleague. Hugh's the Energy Network Manager within Clyde Gateway. So going to delve into a little bit more detail about those projects that Martin referenced, and particularly interested to hear from Hugh about D2 grids and the work ongoing on that particular agenda. Hugh, thanks for joining us, and I'm going to share your slides from my end, I think, aren't I?
Yes, thanks.
I'll try and do that now. The technology works. Okay, can you see that?
Yeah.
Yeah, okay. Seems to be working, yeah. Thanks, Hugh. So just give us a nod when you need me to move on.
Yeah, sure. Okay. Yeah, starting off with the bridge again, of course, we like our bridge, but it does actually play, as Martin says, quite a key role, and I'll touch on that when we come to D2 grids, about connecting our communities, and particularly in an energy context. Bridge was delivered in 2015, so it's been in place for some time, and hopefully we're now going to see the benefits of how that can actually work as an asset to deliver wider energy objectives. Next slide. Just showing the context of where we sit in Glasgow. We're in the wee sort of red blob there in the East End, straddling the River Clyde, covering both Glasgow and South Lanarkshire communities. Next slide. So just touching on the sort of strategic context, the landscape for energy is obviously quite complicated in some ways, and the drive that we're trying to achieve for energy decarbonisation offers a range of opportunities, but sometimes it can be quite difficult to kind of home in on the ground what practical solutions fit best in terms of what your energy requirements are. Next slide. There's a whole range of documentation that we've looked at and been involved in from our Energy and Carbon Master Plan back in 2012, right through to the most recent activities around the Energy and Carbon Master Plan for Clyde Mission. And inputting to a range of these policy documents has been fairly key to sort of straddling out what that landscape should look like. And that impacts on the timeline as well. So some of that information has obviously changed as we've gone through this journey, and changed the types of approaches we've taken through that. And we've tried to be consistent in terms of the approach we've taken to make the most of local assets in the context of how they can achieve energy needs as we go forward. Next slide. So it's just setting out here our energy project areas. So this is kind of homing in the grid area that Martin referred to earlier. The green zone is essentially highlighting Dalmarnock on the north side of the river, where our community energy project has been installed in partnership with Scottish Water Horizons. That in itself, again, is part of a long journey. So we probably looked at this back in around 2015, went through a whole range of iterations in terms of what schemes suited the area best in terms of infrastructure first, what was going to provide resilience, and what was going to actually be workable in terms of the development of that site going forward. And in that sort of context, we've looked at how the master plan should be developed, and particularly in customer connection timescales, etc. That has kind of thrown up a range of solutions that we looked at in terms of what was the best fit. The current energy project looks at initially a combined heat power engine, but now with the introduction of heat pump technology, with a view to looking at the future development of that. We appreciate that, that initial scheme, as many sort of third, fourth generation district heating schemes were using the technology that's available at the time. CHP was obviously, it still is in many ways, a common technology. But there was an impetus to actually get infrastructure in the ground and to look at what the long-term energy solution was. And one sort of key component of that, I suppose, looking towards touching on D2 grids further down the line here, is that issue around, is the solution a large-scale solution, or is it a more modular, individual type solution? And that's quite a fundamental point when it comes to supply chain issues, in terms of how that should be rolled out. And that's kind of one of the key concepts of what D2 grids will look at. We took the view that in terms of Dalmarnock, we had the adjacent wastewater treatment works. That's an asset that has great amounts of potential. And we saw that the best approach to that in terms of our Energy and Carbon Master Plan was to reinforce that local resilience, using local assets, and sharing those assets for wider and long-term needs. The next project that I'll talk about is D2 grids. So just jumping back to that one, on the purple zone, again, Martin highlighted that in his slides, where across the River Clyde, we'd look to deliver the 5th generation scheme here. So we're moving quite quickly, if you like, from a more traditional district heating scheme to a much more bespoke, more modern, if you like, 5G DHC scheme. And that in itself has got a range of challenges that we've looked at. But the fundamental connection to all of these is integration. And that seems to be a fundamental requirement about how to do that. That in itself raises a whole range of issues around smart technology, how systems talk to each other. But again, very much built on the premise of how do you deliver large-scale district heating and cooling as a long-term solution to get to 2045. And just the next slide The third sort of context to this, again, Martin touched on it, but is geothermal mine water. And whilst it's a largely science-based project that we're involved with British Geological Survey, the intention is that some form of demonstration is developed out of that context. And there's a good reason why it's considered here. We know the level of mine workings under Glasgow. I think one can walk right through from Glasgow to Wishaw, as I understand it. Not that I've tried it myself, but there is huge potential in this zone for geothermal energy. And combining with the lessons learned and ongoing work with our European partners, D2 Grids, that's teaching us a lot of lessons about what's the best use for geothermal in the context of the wider integration of energy systems. So Scotland in itself is moving a lot more rapidly now, for obvious reasons, than perhaps the longer journey that many of our European colleagues have had. But it is offering the potential now to look at how we can integrate all of these systems towards the best solutions for the future. Next slide, please. So this is just a wee slide to show the current layout of our district heating scheme. So the black lines are showing what we've actually installed in terms of steel insulated pipe, district heating with the wee energy centre in Scottish Water, Wastewater scheme at Kilmarnock on the top left. We've installed that, future-proofing the area, and as Martin says, we will connect most of the sites, if not all of the sites within Kilmarnock, to that system. And that will deliver low carbon benefits as part of the longer term agreement that we have with Scottish Water Horizons for energy generation, using initially combined heat and power, but moving at some point and introducing heat pump technology almost immediately to that scheme, with a view to further decarbonise and heat going forward. Next slide. And again, just touching on what Martin said, this is our initial connections that will be customer connections to the scheme. Eastworks, which is due to complete early next year, will be the first customer connecting, and a range of other residential customers coming on board shortly. Next slide, please. So the context really in moving forward from largely third and fourth generation type systems for district heating is this concept of 5G DHC, and this is one of the key planks of our next stages, and it's part of a kind of very quick learning journey towards what the future offers. This might not be the best slide really to show that transition, and in many ways 5G DHC, so we'll talk about, is almost an entirely bespoke, entirely different type of system, with a view to looking at it in the context of how it could perform a part in long-term solutions for energy needs, so that, you know, as far as the market's concerned, it can see that there is an appropriate workable solution that can be delivered over the next 10-15 years as part of our energy objectives. Next slide. So the principles essentially around D2 grids are then become quite different from third and fourth generation district heating, looking at offering much more sort of flexibility in terms of how energy can be provided using very sort of low energy sources for heat recovery, and looking at how we can combine heating and cooling as part of that. It's very much driven, of course, by the efficiency of the system, and it does need obviously a sort of fabric first approach in many ways, from the retrofitting and new builds, to offer the potential that it can really deliver. But essentially looking at as passive a system as possible that provides that flexibility and very much controlled in the demand side at the building locations. So the next slide is showing just a concept of what we are actually looking at now in terms of how that system gets delivered. So again, building on using local assets, again working with Scottish Water Horizons, we are looking in this instance at abstracting from the treated effluent within the wastewater treatment works, and installing pipe work that will allow, through a heat exchanger, an ambient loop, plastic pipe ambient loop to be developed, which would cross the smart bridge from Kilmarnock to Shawfield and seek to deliver that potential to individual buildings on the Shawfield side of our national business district. And it's very much based on, as I say, a passive approach to managing that energy needs, so that there's not so much a flow and return system here, but a warm pipe, a cold pipe, where effectively the buildings are the drivers for managing their energy needs and between buildings within that loop. And that's very much the basis of that concept going forward. And it does seek to try and develop a modular approach to that. So not necessarily looking at very heavy capital investment initially, but with the scope to add to connections in a very modular and scalable fashion. Next slide, please. So the design sort of concept is very much based on the thermal improvement of buildings and that bi-directional flow of energy to make the best use of the systems, incorporating in buffering in relation to thermal storage and sophisticated control mechanisms to manage that energy requirement. We're moving on to include an element of both solar PVT and battery storage as part of that. So it very much becomes the case that the thermal and power grid interface is a fundamental part of this, and it's a fundamental part of the business case to support the long-term delivery of 5G DHC. And of course, we can't get away from the fact that that whole issue around the very prominent discussion just now around electricity and gas pricing is really fundamental to achieving that. Next slide, please. Again, just showing the sort of context now of what D2 Grids looks like. Again, it has the connection at site 1 with the energy system and energy centre, and the wastewater treatment works, and then the ambient pipe loop running from the energy centre across the smart bridge and connecting our initial 3 buildings in the Shawfield side, which includes a retrofit as well as new build connections. That will look at also delivering the connections to the north side on that plan for the rest of the buildings, around another 12 buildings or so that we'd hope to connect. So it's a long-term project. The demonstrator will at least connect the initial 3 buildings, but certainly with a view to developing that further. And the business case essentially is predicated on that. We're very conscious that we're driving the financial scheme, the business case, alongside the technical case, and that achieving also an energy pricing mechanism, which is targeted at around £25 per megawatt hour in terms of energy pricing for customers, so that in fact it becomes a potentially viable and attractive option for businesses and residential customers going forward. That's fundamental to developing that. And in terms of the supply chain side of that, we're very much looking at how we can deliver fully funded this demonstrator, but with a view to how that can be extended going forward. Next slide, please. So the options that are available to us in terms of energy usage are all there. As Martin's highlighted, the technology and the expertise are there to be accessed. We can see that potential in the wastewater system that we've touched on, and the potential in the mine workings. We do have those networks available to achieve that. On the customer side, it becomes 5G DHC becomes a key component of energy requirements, of energy statements, and achieving that level that allows compliance to be achieved as part of that. And that becomes again mixed in with the business case and how that can be potentially rolled out. So we look towards in the model, and we have some of the European partners that we're working with on that, to develop that model in a modular context that allows it to be extended and into the longer term on the basis of a viable business case. Next slide, please. The smart bridge we've touched on, again, just highlighting some of the key elements in terms of the technical solution. So the structures that we're dealing with, both in terms of the contracting side and wider operation management, all become very key to what services can be delivered here. And the importance of local resilience in that supply chain is equally critical to that process. So from the whole context of developing local materials, supplies, skills, using those effectively as possible to deliver these schemes. But the issue then becomes, are we geared up enough essentially to be able to deliver these wider modular extensions to a scheme such as 5G DHC going forward, in terms of the skills base, in terms of the system design, etc., to make it a long-term solution. Next slide, please. So again, we're looking at using local assets. There are a whole range of issues that we're still looking at in terms of how we interconnect systems, what we can do using local resilience, local expertise, local manufacturing, etc., to be able to deliver these systems, crossing bridges, etc., as part of that process. Next slide. We've touched on the customer connection side. This is an existing building at Red 3 Magenta, one of the buildings we'd be looking to retrofit as part of the D2 grid system. Again, it has its own sort of range of challenges in terms of how do we fit 5G DHC into that type of system. That's the activities we're looking at. And there are a whole range, I think, of opportunities around that in terms of heat pump technology and integration that can be incorporated into that. Next slide. So again, just touching on customer connections because it becomes very important in terms of demand-driven schemes and how we're approaching that strategy. That will be a combination of using expert design skills that we've taken on board in terms of the procurement of D2 grids, but also in terms of the connection between the deliverability of this scheme and long-term operation management, metering and billing functions, etc., that all flow in to this particular type of scheme. Next slide, please. Again, touching on that whole issue of plant equipment, and I think it's a key area to focus on. I know that different areas of activities around energy are focused on different aspects of that, but we can't dismiss the fact about how critical these are to the long-term supply chain for delivering long-term systems such as 5G DHC. It has to have an integral approach to that system to ensure that it's got longevity as a large-scale energy provider. Next slide, please. And similarly, the types of solutions that we're going to look at for customer connections in the adjacent buildings at Red 3 Central, which will be our next building, they all offer up a whole range of different approaches. So some initial buildings may be looking at air source heat pumps, others might be looking at other types of arrays. But essentially, in order on the ground to make a significant impact in terms of the carbon targets, there has to be a clearer strategy in terms of how different technologies are going to achieve wider priorities, and they need to be prioritised in their own right to what they can deliver. We know that our European partners who have more broadly been experienced in 5G DHC in the European context do highlight the fact about how important it is to have key concepts clearly understood within the marketplace. And that's a key driver, I think, that comes out of probably some of the discussions that we've had over COP26 as well, about how we reinforce the supply chain, the local supply chain's role in that wider context. And that's something we're keen to do in terms of delivering the wider scheme. Next slide, please. And again, it fundamentally is going to help to drive the wider regeneration of Clyde Gateway. We see it in the context of where we sit in the city centre, and it's very much a case for us that Magenta and the Shawfield side, our national business district, will become a key driver that can then be extended beyond Magenta in terms of delivering 5G DHC. Next slide, please. So just kind of finally, just some of the key drivers. We're very much focused on what the policy context is telling us, and it's very much the case now that in terms of the current context, the Clyde Mission Energy Master Plan is going to be absolutely key to how energy projects along the River Clyde are going to be delivered going forward. A key objective of that is what the mass adoption options are going to be to achieve carbon reductions, and that kind of touches back to the point I'm making around D2 grids. There are other options, of course, as well, but it's very much a strong emphasis from what's happening in the European context as to what types of easier fit, flexible, modular, scalable systems can be delivered that can achieve transformational change within the context of the 2045 target. Of course, a sustainable business model is absolutely critical to that. And as I say, that's why we're driving that assessment alongside the technical case. And what we're looking at the moment in terms of achieving the pricing standard against the CapEx that we have looks that the modularity of 5G HD is achievable within a range which we think can be carried out. Our partners in D2 Grids, Open University and Asper Investment Management have long-term rollout works packages, commercialisation works packages as part of that process. And that will be a fundamental element as to delivering that full business case model that we hope can be applied across the board and potentially roll this out in a wider national context for Scotland. Just finally, just showing your potential build out at Magenta and our next steps to connect all of these buildings to our system. So that kind of wraps it for me. I'm quite happy to take any questions now or later.
Thank you very much. Thank you very much, Hugh. There's a lot of detail and valuable information on the work that you're leading within the Clyde Gateway site, and some fascinating insights into the technology and how the future will look, particularly around 5G DHC that you expanded on during your presentation. So thanks for that. I think if you don't mind, we'll move on and then try and handle Q&A together at the end, if that's okay. I'm going to stop sharing my screen now. Actually, no, because I'm going to be sharing my screen for Presley's slides, aren't I, Presley? Hi.
Yeah.
Yeah. Hi. So just a quick introduction again to Presley Maguire from Scottish Water Horizons, our next speaker. Presley's going to be talking a lot more about the heat from wastewater technology. Obviously, Scottish Water Horizons, as Hugh intimated just before, those partner for the Energy Centre at Dalmarnock and the associated district heating network. As I understand it, Presley, you've got a lot of experience in the heat from wastewater technology. I mentioned before Borders College and Stirling Energy Centre, I think you're going to talk about, and not just Dalmarnock obviously, but Equilibrium on the Mull of Kintyre as well would be great to see how it's being used there. So just bear with me and I'll come back to the PowerPoint presentation and see if we can get your slides up. You can still see those?
Yeah.
Perfect.
Perfect. Thank you very much. Thank you. So hi everyone, my name is Presley Maguire and I'm responsible for the operation and maintenance of Scottish Water Horizons low carbon and renewable energy assets. So before I start my presentation on how we are helping to decarbonise heat in Scotland, I thought I would give you a bit of a background to who we are and what we do as a business. Next slide, please. So Scottish Water Horizons is a commercial subsidiary of Scottish Water aimed at developing opportunities and the sustainable development of Scottish water assets. So Scottish Water has hundreds of treatment works, reservoirs and thousands of miles of water and wastewater pipes. And by capturing the opportunities that these assets provide, we're helping our customers, our environment and our economy thrive. From generating green energy from wind, solar and wastewater to recycling food waste and driving industry innovation, we're contributing to Scotland's ambitious net zero targets to secure a low carbon future. We're also harnessing Scottish Water assets to extend high-speed broadband to remote locations and delivering water and wastewater infrastructure to support some of the biggest developments in Scotland. Next slide, please. So throughout our own development and working in partnership with both the private and public sectors, we are generating renewable energy through the installation of wind, solar and biomass schemes and at our treatment works to reduce our reliance on traditional energy sources and lower our carbon footprint. We are treating and safely disposing of a variety of liquid wastes, including organic sludges, landfill leachates, and septic from a range of commercial and industrial processes at our network of licensed treatment facilities. We're driving innovation by facilitating access to our water and wastewater development centres to enable users to test new technologies, processes, and equipment in live operational scale, low-risk environments. We're facilitating the installation of innovative heat from wastewater technology to provide cost-effective low-carbon heating. And we're designing, building and delivering new water and wastewater infrastructure to support the build of some of the biggest housing developments in the country, including Scotland's first new town in 40 years, Tornagreen, which is near Inverness. And lastly, we recycle food waste into green energy using our modern anaerobic digestion technology at our recycling facility near Cumbernauld. Around about 145,000 tonnes of food waste from local authorities, food producers and businesses have been recycled since commissioning of our plant in 2010. So I hope that's given you a bit of an insight into the things that we do at Horizons. I'll now move on to discuss how we're helping decarbonise heat. Next slide, please. So if we look at Scotland as a whole, in 2019, Scotland's energy consumption from the heat sector was 51%, and 18% of Scotland's greenhouse gas emissions resulted from heat, mainly the burning of fossil fuels. Now, one of the headline targets in Scotland's energy strategy is for the equivalent of 50% of energy for Scotland's heat, transport and electricity use to come from renewable sources by 2030. Additionally, to meet Scotland's net zero target by 2045, all homes and buildings in Scotland must have significantly reduced their energy use, and almost all buildings must be using a net zero emissions heating system. Therefore, there is an urgent need to move away from traditional gas boilers and find sustainable carbon-saving methods for generating energy. So what part do Scottish Water and Scottish Water Horizons play in helping Scotland meet these ambitious targets? So Scottish Water is committed to delivering net zero, and we have set ourselves targets to deliver net zero by 2040 across all of our operational and construction activities. In September 2020, so last year, we published our net zero route map, which outlined how we will achieve this. Over and above the work that we need to do to deliver net zero, and as part of our 25-year business plan, we defined a purpose for Scottish Water, which is to support a flourishing Scotland. And we're looking to use the assets and resources that we currently have across the country to support the wider Scottish economy. Over 921 million litres of wastewater is produced in Scotland each day, and Scottish Water operate over 31,000 miles of sewers and are connected to over 90% of properties across Scotland, which represents a considerable opportunity to develop local low-carbon energy generation. And by tapping into this resource and using proven heat from wastewater technologies, we are able to recover heat from wastewater in the sewer network. Next slide. So wastewater, also known as sewage, consists of what gets flushed down the toilets, but also includes millions of litres of hot water from showers, dishwashers and washing machines. And thanks to this, it has a fairly constant average temperature of between 13 to 20 degrees, which makes it an excellent source of energy. And until recently, this energy simply flowed down the sewers to treatment works unused and was lost. However, using a filtration and heat exchanger process, heat from wastewater can be transferred to heat pumps to produce low carbon heating and hot water. Next slide. So I don't know if you'll be able to see that diagram that well, but hopefully when the slide packs get sent out, you can have a look at it in a bit better detail. So how exactly does wastewater technology work? So the process boils down to a few simple steps. Commercial and domestic wastewater goes out to sewer. We extract wastewater either directly from the sewer or from within wastewater treatment works. The extracted wastewater enters a heat recovery unit, which separates the liquid and solid waste. The solid waste is returned to either the sewer or the treatment works, but the liquid is passed through to a heat exchanger. The heat exchanger then captures the residual heat in the wastewater, and this heat is then transferred to the clean side of a closed loop. The heat is then amplified by heat pumps, and then the resulting hot water is then delivered to the end user. I would just like to stress that the wastewater does not come into direct contact with the clean water in the closed loop system that is delivered to end users. So I would like to assure you, as this has been a genuine customer question, that although the heat is extracted from sewage, that doesn't mean you actually have sewage flowing through your radiators. So I will now move on to highlight 5 projects where we have either facilitated the development of or installed our sewage heat recovery schemes. So the first project I will speak about is Borders College. So this wasn't a Scottish Water Horizons led project, but we did facilitate access to the sewer network to help deliver low carbon heat to Borders College in Galashiels. This was the first heat scheme of its kind in the UK. The project was backed by investment from Equitex and the UK Green Investment Bank, and the heat recovery system intercepts wastewater from a sewer close to the local treatment works, which is operated by Scottish Water. Although the heat is going to a single user, the college, it is in effect a small district heat network, as there are several buildings that are connected to it on campus. So the system, which was commissioned in 2015, is housed in a purpose-built energy centre designed to fit in with the existing aesthetic of the campus. And the sewage heat recovery scheme provides around 95% of the heat needed by the campus. It does not impact on the normal operation of the local wastewater network, and it reduces carbon emissions by over 150 tonnes per annum. Next slide. Stirling Energy Centre. So this was one of our first heat from wastewater schemes. We installed heat from wastewater technology alongside a combined heat and power engine to provide low carbon heat to a district heat network in the Forthside area of Stirling. The Energy Centre is located within the boundaries of Stirling Wastewater Treatment Works, to which the CHP actually provides power to. The technologies used for the first time together in the UK are providing heat to a number of end users. The heat recovery system intercepts wastewater from within the treatment works, so we actually extract the wastewater after the primary screening stage. The £6 million project was a partnership between Stirling Council and Scottish Water Horizons, and it was partially funded by the Scottish Government's Low Carbon Infrastructure Transition Programme. Next slide. So on this slide, you'll see a map which shows the location of Stirling Energy Centre, and the blue dashed line is highlighting the district heat network which Stirling Council own, operate and maintain, and the end users we currently supply heat to. So some of the end users include Forthbank Stadium, so that's the home ground of Scottish Professional Football League club Stirling Albion. We've got the Peak Leisure Centre, St Modens High School, Forthside Conference Centre, and the offices of Zero Waste Scotland. A point that I would like to highlight is that the Leisure Centre provides a year-round baseload for the system, which is key in helping to justify the business case and investment in a project like this. So Scottish Water Horizons own and operate the Energy Centre, and as I mentioned before, the Energy Centre is located at an existing wastewater treatment works, to which we provide power to via the CHP. We sell the heat produced from the heat pumps in the CHP to Stirling Council at an agreed rate, which the council then sells to users via the heating network. Using local company FES, the project was completed in October 2019 and has been designed to provide further capacity as heat demand increases and the council expands its network, helping to tackle fuel poverty and providing savings for businesses. The scheme has continued to supply heat and electricity throughout the pandemic, albeit at reduced volumes due to lower demand, as some buildings have been empty or were empty during lockdown. The end users connected to the network are set to save 10% on their energy bills. Next slide. So Dalmarnock Energy Centre. So we're installing a 200 kilowatt heat pump and 1 megawatt CHP to provide low carbon heat to another district heat network just to the east of Glasgow. The Energy Centre will be located beside Dalmarnock Wastewater Treatment Works, and the CHP will provide power to the works as well as the CHP and heat pump, providing heat to a number of end users via the district heat network. So this was a £6 million project, and it is a partnership between Clyde Gateway and Scottish Water Horizons, and it was partially funded by Scottish Power Energy Network's Green Energy Fund. The scheme is designated as Scotland's first green regeneration and innovation district, and homes and businesses across the Clyde Gateway site will be heated using the new system and allow people to live and work in a low carbon and resilient community. The system will provide an instant supply of heat and hot water using a metered system that ensures residents and businesses only pay for the energy that they use. Initially, 50 homes in Clyde Gateways new Eastwork offices will be connected to the district heating system, with plans to connect over 300 homes and commercial businesses over the coming years. So the heat recovery system at Dalmarnock intercepts wastewater from final effluent, which you touched on. And this differs from the setup that we have at Stirling. So if you recall, at Stirling, we extract wastewater after screening. So by intercepting wastewater from the final effluent, this has the following advantages. The flow of water is relatively constant and the wastewater is cleaner. Therefore, this reduces the likelihood of downtime as a result of the build-up of rags within pipework and the mechanical wear of equipment due to grit. A social benefit of district heating systems that I would like to call out is that it can help alleviate fuel poverty, as the costs for heating are generally lower compared to gas. And similarly, wastewater is not susceptible to shortages or unforeseen price hikes, which, as we will all have seen in the news recently, this has been happening to gas. I would also just like to highlight that at Dalmarnock we trialled some low carbon construction materials. So the access road into the energy centre is constructed not with conventional tarmac but recycled plastics. And this scheme is due to be operational by the end of the year. Next slide. Equilibrium Leisure Centre. So we are currently installing a 1 megawatt sewage recovery heat scheme in Campbelltown. The installation will see wastewater being intercepted from Scottish Water's adjacent Kinloch Park pumping station and natural residual heat from that being extracted and amplified before being channelled into the leisure centre. The leisure centre and swimming pool is operated by Argyll and Bute Council, and the project is estimated to meet 95% of the facility's heating demands and use just 25% of the energy it currently takes to heat it with mains gas. The new heat recovery system will be integrated into the council's existing heating infrastructure, and the system will heat the 25-metre swimming pool, the fitness suite, steam room, sauna and library, and it's due to be operational by the end of the year. Now, there are wider emissions benefits here, as Campbelltown is a gas island, so it's not actually connected to the UK gas grid. So all of the gas used in Campbelltown is actually transported up from Essex, I believe. So you get an additional emissions reduction here as a result of reducing the number of tankers that are travelling up and down the country to supply that network. And I would just like to highlight that there are a number of other gas islands in Scotland which could benefit in the same way if heat from wastewater schemes were to be adopted. Next slide. AMIDs. So the project, which has been led by Renfrewshire Council, will provide low carbon heating to a 5th generation ambient loop district heat network supplying the Advanced Manufacturing Innovation District Scotland, and that's the acronym for AMIDs. So, and this is going to be located next to Glasgow Airport. The project is supported by significant public sector investment. The AMIDs project will be home to the National Manufacturing Institute Scotland and the Medicines Manufacturing Innovation Centre, as well as 2 existing major research centres operated by the University of Strathclyde, the new Lightweight Manufacturing Centre and the Advanced Forming Research Centre. Referencing success we've had in the past with the low carbon district heat network in Stirling, the team behind AMIDs approached Scottish Water Horizons to see how we could support with something similar. So working with a number of teams internally from within Scottish Water, we were able to facilitate access to treated effluent at one of our sewage treatment works in Paisley, which will be used to provide heating to the network. So heat exchangers will transfer the heat from the wastewater to the clean water side of the system, which will then be pumped around the ambient heat network. So each building connected to the network will have its own individual heat pump, which can heat the water as needed. The connected customers can also use the network for cooling by rejecting heat from their building back into the network. So this is unlike our previous projects where the heat is amplified at the energy centre before distribution. One of the key benefits of this is that the expensive pre-insulated pipes are not required to carry the ambient temperature water. So that results in increased financial viability of expanding the network as the AMIDs campus grows. This scheme will deliver a 90% reduction in carbon emissions compared with conventional gas heating systems, so a big contribution to Scotland's journey to net zero. Next slide. So that's an overview of some of the projects we have been involved in and delivered, and clearly there is a lot of potential to extract heat from wastewater. As we have facilitated the development of and installed or in the process of installing a couple of our own heat from wastewater recovery schemes, Our team has learned a great amount from these innovative schemes. For instance, we understand how to best integrate different technologies into a single scheme. So for example, Stirling and Kilmarnock, we've got the CHP and the sewage heat recovery, retrofitting district heating into existing buildings and structuring contracts for such arrangements. For example, heat supply agreements, design and build contracts and O&M contracts. Our supply chain is also becoming more experienced, now having done a number of these projects. For example, FES, who are responsible for the design and build of the heat recovery projects at Stirling and Kilmarnock, they are also our O&M contractors for both of these schemes. So we've gained a wealth of knowledge and experience in operating and maintaining these types of assets. They have also just secured the contract to complete the network for the Amons project, so I'm sure they will be feeding any lessons learned from Stirling and Kilmarnock into this project. We also worked with Rambo, whose work covered concept design of the energy centre, heat network and building interfaces, and I believe they have provided consultancy services to more than 200 companies worldwide. And we're always looking for partners who are looking for renewable heat to develop projects. Next slide, please. So lastly, challenges for the technology can be quite site specific. So for example, the system is best suited to 4th generation heating, which runs at around 60 degrees, or 5th generation systems, which operate at ambient temperatures that can be increased to the required level at each individual building. So this means that if the building is being retrofitted to connect it to a district heat network, then emitters such as radiators may need to be upgraded. So lower temperature systems such as 4th generation networks may need larger radiators with a greater surface area to emit the same amount of heat as a traditional system running at around 80 degrees. However, this isn't always the case. At the project at Borders College, that didn't need to have a single emitter to be upgraded because they were actually already oversized. The location, age and depth of sewers. So in the majority of our projects, we have intercepted wastewater from within treatment works. However, energy can also be recovered upstream in the sewerage network. However, developing extraction points to do so would enable distributed energy projects to be installed closer to users, which would improve efficiency. And as I mentioned, Scottish Water operates more than 31,000 miles of sewerage network, which represents a considerable opportunity. And in many cases, the heat is literally passing by the customer's door. However, depending on the location, the sewers may be deep and old, and in these circumstances, it can be technically more challenging and costly to access them for energy extraction. Attitudes. So one of the main challenges to date has been changing the attitudes of surveyors, architects and consultants and energy managers, so they are prepared to consider something that sounds quite left field compared to conventional gas boilers. Economic, so our wastewater heat recovery systems are currently subsidised by the UK government's non-domestic renewable heat incentive. However, this scheme is due to close in March next year, and I do not believe the government has announced what, if anything, will replace it. And in most circumstances, the technology will not be able to compete with mains gas in terms of cost. However, with the focus of many businesses, local authorities and surveyors on the commitment to net zero carbon, the importance of sustainable energy must not be overlooked. And that's me. Thank you very much. I'll take any questions at the Q&A session later on. Thank you.
I'm just starting my mic and video. Thank you very much, Presley. That was excellent presentation covering all of the schemes that you've either been involved with so far or are currently involved with and looking forward to as well. It's fascinating some of the statistics that you shared with us this morning. Was it 921 million litres of wastewater each day in Scotland? That was quite mind-boggling. But maybe more relevant was the carbon reduction of AMIDs that I noted down there. Did I get that statistic right? Your technology is 90% more effective at reducing carbon compared to a conventional heating.
It's not our technology, so it's just the scheme. Okay. Scheme will deliver 90% reduction in carbon emissions compared with conventional gas heating systems. Yeah,
I'm with you. Okay. If you don't mind, we're just going to pause maybe 5 minutes. We've got a little bit of time, so if we can go through some questions now before I introduce Anne-Marie from Construction Scotland Innovation Centre to prevent a kind of build-up of questions that we have at the end. So Hugh, you're still with us, aren't you there? And Presley, there's a couple for you. Hugh, first of all, looking back to Clyde Gateway, are you working with Scottish Waterways? There was a question initially around Scottish Waterways. Are they a partner or stakeholder of yours?
No, not specifically. No, that's in terms of the canals. Is that? That might be
I mean, there's Scottish canals, isn't there? I don't know whether
but no, not directly Scottish Waterways in our local context anyway.
Okay. There was also regarding heat pumps inside or outside of buildings. In your experience, is it possible to place a heat pump inside a building? Because you most often see them outside, don't you?
Yes, I mean, in terms of how we're looking at Magenta, they are designed to be installed within the buildings.
Okay.
Although one of the concepts, it really depends on the mixture of end user connections, depending on the sizing and maybe different scales of building connections. They may lend themselves to mini hub solutions. So we're looking at the concept of adjacent heat pump hubs, but also which incorporate the solar PV battery storage elements. So you have all of those elements that interconnect with the thermal and power grids in the one location, but are capable of linking to all of the buildings. So there's different sort of concepts there in terms of what are the most efficient solutions. But the key driver for what option you go with is very much dependent on how you want to integrate the thermal and power grid solution.
Okay, thanks for that. And just quickly regarding timescales for the Magenta project that you spoke about, when will it be completed?
We're expecting connections to be made around the middle towards the end of 2023, with then subsequent buildings connecting over the next 5 to 6 years.
Okay, thanks for that. Presley, you may be able to answer the next question that we've had on the chat regarding delivering retrofit of wastewater for households. Does that involve heat pump installation?
I'm actually not too sure on that one. We haven't been involved with retrofitting for households, and when we have retrofitted for buildings, it's usually the team that are looking after the network. So for Stirling, that would have been Stirling Council.
Okay.
But I'm not actually too sure for households what's involved and how long it would take.
Okay.
So apologies for that.
No problem at all. No, let's come back to that one, and maybe someone in the audience can help with that question that Harry has asked. There's also a question regarding the water utility suppliers in the rest of the UK. Are they, to the best of your knowledge, Presley, undertaking similar schemes around the district heating network?
So I know our project at Stirling, which was using the CHP and Sewage Heat Recovery system, so that was the first of its kind in the UK. So other water companies are aware of it, and they'll also be aware of the project that we are doing at Dalmarnock. So I would like to believe that they are looking at that and currently investigating it. Scottish Water does regularly speak to other water companies in the UK, so I'm sure any lessons learned are being shared with them.
Yes. Yeah, I mean, from our point of view, it'd be good to expand on this and maybe bring together some other water companies, and we can have a follow-up event specifically on this technology in terms of best practice and lessons learned, because we're bringing together some Anglia Water, Yorkshire Water, with other providers as well. So if you're interested, we can get Scottish Water and Scottish Water Horizons involved in that type of event in the new year. Alan Rogers from MVP Energy has messaged saying that they have a wastewater treatment process that works at very low temperature of sewage, which would fit well. So it might be interesting for Alan to have a bit of follow-up with yourself, Presley, and colleagues regarding their technology over at MVP.
Yeah, Scottish Water Horizons, it does have 2 dedicated test facilities that enable low carbon technology to be tested. So please have a look at our website, and you can get in contact with us. I believe the email address is hello@scottishwaterhorizons.co.uk. Okay,
yeah, I think you've just answered the next part of his question. What's the most effective way to gain acceptance for an innovative carbon reducing process for wastewater? So you don't mind, Alan, following up to get a little bit more information on you from you on that? Okay, let's press on now to our next speaker, and we can come back round to any of those points or other questions that the audience might ask whilst Anne-Marie is giving her presentation. Good morning, Anne-Marie. Thanks for joining us. You work, as I understand it, for the Construction Scotland Innovation Centre, but you're also heavily involved with the Energy Technology Partnership, and you're going to share with us a little bit of your knowledge and experience of providing support and assisting innovation on energy efficiency as a whole and low carbon technology in the built environment. So thanks for being with us today. And is it okay if you share your slides? Have you got them at your end?
Yeah, I'll just share mine. Thank you.
Okay, perfect. I'll stop sharing my screen, and that should allow you to take control.
Okay, so hopefully you can all see this.
Yes, just come through now. Thanks, Anne-Marie.
Okay, perfect. So hello everyone. So my name is Anna-Marie Gillespie, and I've been invited to talk to you about energy efficient buildings and low carbon innovation. So like Andrew mentioned, I'm a shared resource, and I split my time between Construction Scotland Innovation Centre and Energy Technology Partnership. So I wanted to give you an overview of both organisations and talk a little bit about the work that we do to help Scotland reach net zero by 2045. Right, there we go. So at CSIC, our aim is to support the built environment to achieve net zero carbon through innovation within the construction industry. We are one of 7 innovation centres in Scotland. They're listed there at the top of the slide. And we are funded by the Scottish Government, Scottish Funding Council, SE and Highlands and Islands Enterprise. So the way we work is very collaborative, and we bring together industry, academia and the public sector to work on innovative projects. We have a 35,000 square feet innovations factory, which enables the industry to experiment, build prototypes and trial new equipment. So when it comes to energy efficiency in buildings, I wanted to first give you like a snapshot of where we are with our existing building stock in Scotland and highlight some important statistics. So today, approximately 80% of Scottish homes use mains gas as heating fuel, and only around 11% of homes have low carbon heating systems. And from an energy efficiency side, less than half of our homes in Scotland achieve an EPC of C or higher. And as we're specifically, or we have been talking about Glasgow quite a lot during this webinar, it's worth mentioning that old tenement flats account for approximately 28% of urban housing stock in Scotland. So now when we know where we are, but what is it that, where is it that we want to get to? What are the targets? So the Scottish Government's heat and building strategy sets out the pathway to zero emissions buildings by 2045. And according to this strategy, all homes should meet an EPC standard of C or above by 2033. So it's vital that the fabric of our building stock will be significantly improved, as by doing this, we reduce energy demand and ensure that our homes are easier to heat. Another target is that by 2030, over 1 million homes will be installed with low carbon heating systems. And I'm sure that we can all see that these statistics and the targets set by the government highlight the size of the tasks that we have in hand. So now it's evident that there is a strong correlation between a successful rollout of low carbon heating systems and the energy efficiency of the built environment. And we also know that the decarbonisation of our heating systems will not be successful without a fabric first approach. So installing a heat pump, for example, into a leaky building is just not feasible. So I'm talking, so obviously there's been a lot of talk about heat pumps and the district heating system. So I'm now talking about more of like an individual heat pump to a, for example, a detached home that is just not been sufficiently insulated. So we have at CSIC developed programs that support the construction industry to move to enhance energy efficiency in buildings in a cost-effective way. And retrofit is one of our key programs, which aims to support projects that increase the efficiency of existing building stock and support the creation of new products and services. Another kind of issue or a concern is the future skills force. So making sure that the future workforce have the appropriate skills is a significant part of our activities. And our future skills program is designed to support industry educators and learners to address skills gaps in the following 4 themes. So there's a culture change, accelerate industrialization, building sustainably, and digital transformation. We also deliver passive housing practice training. And for anyone who hasn't heard about a passive house, it's a gold standard for energy efficient house building. And our program has been designed to upskill or reskill anyone in passive house standards who are at risk of redundancy, unemployment, or want to retrain or multi-skill in passive house standards. And so far, we've had over 100 people taking part in face-to-face training at our innovation factory. And we have also delivered online training to over 600 participants since rollout in March this year. So I wanted to just showcase a couple of projects that I have for this topic. So I mentioned the retrofit program earlier, and one project supported by CSIC looked to establish an installation methodology for the use of super bead insulation to improve the energy efficiency of 3 1919 built solid wall buildings. The outcome from this project was that a new solution for hard to treat buildings with a 63% heat transfer reduction and a commercial benefit for the lead partner and also the installer. Also, something to highlight is that obviously driving towards net zero is not only about insulating our homes, but also about developing low carbon materials. Another project we have been involved in recently was a development of a sustainable brick made from 90% recycled construction waste materials. The brick is unfired, there is no cement, and has 1/10 of the emissions of a traditional kind of red clay brick. The product has won multiple awards and it's had a significant media coverage. It's actually also been featured on the One show on BBC. So you can visit our website to find out more about these or any other projects that we have been involved in. I also wanted to quickly mention that during COP26, which is obviously the topic of the next couple of weeks or another week to go, CSIC's Innovation Factory has turned into an exciting hub of inspiration, learning and action for the built environment to accelerate to net zero. You can find out more about the programme via the link that's on this slide. There is no charge to take part in any of the events or the factory tours, but you do need to make sure that you book beforehand before you visit. So that's very quickly whirlwind of the CSIC. So I want to also talk about ETP. So ETP is an alliance of 14 university partners engaged in world-class energy-related research and development. The program with an ETP that I work for is called Knowledge Exchange Network, or KIN program. So we have a team of 7 business development managers covering different low-carbon technology themes, myself being one of them, and I cover the heat energy. Other themes in our program include solar, wind, marine, bioenergy, carbon capture and storage, and zero emission mobility. So just very similar to CSIC, we also support collaboration between industry and academia. So the KIN program is typically a 3-year funding program for Scottish SMEs within the low carbon energy sector. We are currently on Ken number 3, and this funding cycle is running until end of July next year. And our mission is to support the Scottish Government in meeting its targets for the energy sector, increase the innovation capacity of SMEs in low carbon technologies, and to improve industry access to academic research space. And the criteria for funding support are as follows. So it must be a low carbon project. The potential to commercialise is important as well, and the SME has to be Scottish or have strong Scottish presence. There is up to £10,000 funding can be awarded to pay for a university academic to work together with the SME on a low carbon project. There is a SME contribution of 30% required. This can be either in cash or in kind. So obviously in the media there's been a lot of focus on heat pumps, as this seems to be the most obvious replacement for a gas boiler. But if you consider an urban environment, other systems or technologies might be more suitable. So district heating networks, so it's obviously already been talked about, it's been mentioned by the previous presenters. I did want to talk about geothermal energy. The Scottish Government has supported a number of studies that explore deep geothermal energy potential in Scotland as a source of low carbon heat. And as already mentioned, abandoned mines have been identified to have significant potential for heat energy. And Martin and I think you as well already mentioned, I think this is the problem going last, that there is a research site in the east end of Glasgow, which is part of the British Theological Survey UK Geoenergy Observatories programme. This is funded by the UK government. The site has a network of 12 boreholes that have been fitted with 319 sensors in order to observe how warm water moves around the mine workings. At ETB, we've also funded deep geothermal projects, and we have actually recently awarded a funding for a project that will look at flooded mineshaft potential for thermal energy storage. And the reason I'm interested in this is actually the potential that this might have for the development of district heating networks in Scotland. And district heating networks are already very common in, for example, in the Nordic countries, and I know that in Finland, this is the most common method of heating. So if you would like to have any more information about ETB, here's how to get in contact with us. If you have any questions, obviously welcome any SMEs. I'm not really sure who's in the audience, but any SMEs within this kind of low carbon technologies, if you're looking to do a project, looking to work with an academic, then please get in touch. And also there's contact details for, thank you, that's me.
Thank you very much, Anne-Marie. Really appreciate you joining us this morning and sharing your information on the two hats that you wear. Like me, you've got a dual role and share your time between different organisations, but clearly there's a strong link between both of those. And thanks for sharing the link as well to the events that are taking place over this fortnight, obviously as part of COP26, and I'll join you in encouraging everyone on the call to try and participate in at least one.
Yes, I would really recommend it. The factory is looking very impressive. It's so absolutely anyone.
Yeah. Kind of, we're almost halfway through now, aren't you? And 1 week to go. So yes. All of the information about those events are on that website, aren't they? Be at COP26.
Yes.
Yep. That's great. So are there any more questions quickly for our speakers? I realise that we've run slightly over, and I apologise for that. No one else is to blame other than myself. I thought we had a little bit more time than we eventually did have. So I'm sorry to cut into some time that over the scheduled finish time for this morning's session. But if there's any more questions, we can take those very quickly. If not, then I'm sure, as I said earlier, any speaker would welcome any approach from you via email to find out more about your work and ask for more detailed information from your organisations. We're getting lots of very positive reactions to the information that's been shared this morning, so that's great. If there aren't any more questions, then we won't take up any more of people's time. So thanks obviously to Martin, who had to leave the session early, but really appreciate him joining. Thanks to yourself, Hugh, for explaining more about your work and giving us a vision into the D2 grids work in particular. Presley as well, it's been fascinating hearing about your projects and the carbon benefits and the environmental benefits of using that resource, that hidden resource of wastewater, and ensuring that we can generate heat from that very plentiful, as we've heard, resource. And Anne-Marie, thanks a lot for giving us an insight into the work of the Construction Scotland Innovation Centre and the Energy Technology Partnership. On behalf of everybody, thanks again for your contributions. We will be sending around a feedback questionnaire to everyone on the call, so please do contribute views, and we'll take those into account to ensure continuous improvement of this type of webinar in the future. Find out all you need to know about the Supply Chain School's work, obviously via our website, supplychainschool.co.uk, and the partnering and collaboration and support that we offer for the built environment in terms of education and knowledge and upskilling the supply chains on not just carbon and environmental matters, but all aspects of sustainability. So have a good rest of the day, everybody, and enjoy your weekends, and I'll see you again soon. Bye-bye.